Truth tables. A truth table shows when the resulting value of a compound statement is for all the possible truth values of the simple statements. So our negation, that's really not a compound statement as we talked about before. But our definition of a statement allows for the statement to be true or false, but never both. So consider the statement P, today is Monday. So if it is really Monday, then P is true. The negation, not P, today is not Monday, is false. But if it's not Monday, then saying that Monday is true, that it's really Monday, then that would be false, right? So the fact that it's not Monday would make that true. The next one is a conjunction. So if we have a compound statement made up of two simple statements P and Q, there are four possible combinations of truth values for these statements. We will need to consider each combination every time we evaluate a compound statement containing two simple statements. So we're going to look at the truth of conjunctions. Kate has a cat, Kate has a dog. So remember, conjunction would be and. So if somebody's claiming to have both a cat and a dog, both would have to be true. Both simple statements would have to be true for the entire compound statement to be true. So on the first one, if she has both a cat and a dog, then yes, it's going to be true. But on this one, you'll notice that she doesn't have a dog, okay? So then that makes her claim of having both false. In the next one, you notice that she doesn't have a cat, so that will make that false. The last one, she doesn't have either one, so that makes that compound statement false. Next, we consider the truth table for or statements or disjunctions. Again, let P equals Kate has a cat and Q is Kate has a dog. When will the statement Kate has a cat or a dog be true? So remember, the or would be she has one, the other, or both. So if she doesn't have either one, that's the only situation where this compound statement would be false. So let's take a look here. Kate has a cat, she has a dog, so that's a both. That's true. Second one, she has a cat, at least, so that's true. The third one, she's got a dog, so that's true. On the last one, she doesn't have either one, so that's going to be false. So it's important to note that in set theory, that in logic as in set theory, or is inclusive. In other words, or means one, the other, or both. That's why if Kate has both a cat and a dog, the answer to the question, does Kate have a cat or a dog, is yes. If she does have both, that's part of it. The next one is conditional for the if-then statements. Suppose you place an order online and the company promises that if you pay for the expedited shipping, then you will get the order within 2 days. So we're going to let P be the simple statement you pay for the expedited shipping, and Q will be that you receive your order within 2 days. All right, so let's look at these two situations. If you are paying, in order for their claim to be true, you are going to expect to get the order within 2 days. So in this case, you paid and you got the order within 2 days, so their claim is true. But if you paid and you didn't get the order within 2 days, that makes their claim false because you paid but you didn't get your order. Now, if you don't pay, well, their claim could still be true. You didn't pay, so it really doesn't matter what happens there. So any if-then statement that begins with a false, those are always going to be true. So whatever follows the if is called the antecedent. And then whatever follows the Q is called the consequent. And then lastly is a biconditional. Biconditional statement is really the conjunction of two conditional statements. Again, the conjunction of two conditional statements. So the biconditional statement, he will get an A in the class if and only if he gets an A on the final, is the same as if he gets an A in the class, then he gets an A on the final. And if he gets an A on the final, then he'll get an A in the class. This means that both if P then Q and if Q then P must be true in order for that biconditional to be true. So that means that if we're going from if P then Q, we have a true then false, so we remember from the conditional that would be false. Similarly, we have the if true then false here. If true then false, if we're going from P to Q, remember that would be false. So the both false, remember those are true regardless. If false then false, and vice versa. So I handed out this particular truth table for everyone, just to have it all in one place, and then you will use those to fill out the truth tables on page 22 of your notes.